Hey, today we're covering I2C. I2C stands for Inner Integrated Circuit. It's a serial bus communication where a master can communicate with multiple slave devices. This gives you the opportunity of using not too much wiring and communicate with a lot of different components. We can see here some example of the devices that use I2C: gyroscope and accelerometer sensors, current sensors, digital potentiometers, and magnetometers. These are just some examples of the sensors that sometimes, instead of using analog to digital conversion, some devices are programmed or use a chip that sends the data through I2C. So how it works. First of all, a bus consists, in this case, of two lines. A bus usually has several lines that follow one purpose. So the bus for I2C has only two lines. One, it's the serial clock, which is the one that's used to synchronize the data. It's a clock that oscillates, telling the other devices like where to change from 0 to 1 for the next data. And the other one, it's the data that it's being transmitted. The way that it works is that everyone is connected to the bus, and every slave has its own address, which is a 7-bit address. This means that in theory, we can have one master connected to 127 slave devices. The pins that are used in your Arduino to communicate are A4 and A5, where A4 is your serial data and A5 is your serial clock. So, how do we code it? Well, first of all, we need to use the wire library, which is already in your Arduino. You don't have to install it or download it or anything. Just write it in your include wire.h before your setup. And we can work in two modes. We can work in master mode or slave device mode. The difference is when we write wire begin and setup. If we don't write anything, the Arduino, it's gonna be consider itself a master. And when we want to make it a slave device and a slave device, we have to write the address of the slave, which is a number that can go between 0 and 127. So, for instance, if I write this instruction on this Arduino, this will be the master. And if I write this instruction in this Arduino, this will be the slave device. There's more instructions depending on master or slave mode that we need to consider. Just writing the most basic ones. Like in this case, we're starting with wire begin to initialize this one as a master. The next instruction, if we want to transmit data, we need to write wire begins transmission, and we need to specify the slave address that we want to communicate with. So if you have different devices, let's say this one is address 4, address 7, and so forth. If I write wire begin transmission address 7, I'm communicating only with this slave device. If I write wire begin transmission 4, I'm communicating now with the device on the left. Then I'm gonna send the 1 in ASCII format, and I'm ending my transmission. So these three lines will make the data to be transmitted from the master to slave. On the slave side, we need to initialize it as a slave with address. Notice that both of them have the same address. Then we need to write an event. This is gonna make more sense once we go over the examples, but basically an event, it's a part of code where the Arduino will jump from the loop to notify that something has been received. So in this case, the Arduino, it's right here where it just sent the 1 in ASCII format. That's 1. It's gonna be read in the event and it's gonna be saved into a rex in this line of code. But as I mentioned, I'm just trying to explain in a overview how it works. I think it's gonna make more sense once we start seeing examples about this.